today we'll be seeing one of the question, that is how we can convert the decimal numbers to the binary, right? So before converting the decimal numbers to the binary, so we should see how binaries are looking like. So obviously in the binary you'll be just using the 0 and 1, right? So let's take an example. If I am having a numbers like 1 2, like instead 0 1 2 3 4 5 and so on, right, up till infinity, whatever the numbers are over there. And these numbers, you can say these numbers are the decimal numbers. These numbers are the decimal numbers, and decimal numbers are something which is having the base of 10, right? So in decimal, if I have to write something like 0, I will be saying that this 0 is having the base 10. If I have to write 1 here, I will be saying this the base of this is 10, sorry. The base of 2 is again 10. The base of 3 is again 10, right? So these decimal numbers, what you have to do is you have to convert them into the binary. You have to convert them into the binary, getting this thing. So how you'll be converting them into the binary, that we have to see. So before discussing that thing, let me show you how we will be converting, yeah, how these binary numbers are looking like. So in mathematics you are having these place values like ones place, tens place, hundreds place, thousands place, and so on, right? So here also we are having a place value in the computer science as well. The place values goes like this, from right to left. It starts from 2 1, double the 1 it will become 2, double the 2 it will become 4, double the 4 it will become 8, double the 8 it will become 16, double the 16 it will become 32, double the 32 it will become 64, double the 64 it will become 128, and double it again and again to the left hand side, right? These are your place values. I can say these are my place values, right? So let's take an example. If I have to represent 0, let's take, we are taking only 3 bits. Let's take only 3 bits. We are having something like this: 4 2 1. These are my 3 place values. Getting this point? With these 3 place values, I have to represent the 0, I have to represent 1, right? So what you have to do is 0 means the bit is off, or I can say the place value is off, and 1 means the place value is on, right? If I will say this, 0 means off and 1 means on. This is the thing here, right? So if I have to represent this 0, that means this value should be off. 0 should be off, this 2 should be off, this 4 should be off, all of the bits should be off. Then I can say here it is a 0. That means 0 is represented as 0 0 0, right? Now when you have to represent 1, right, when you have to represent 1, just look at your place values. When this one will be represented, when this bit will be on, right? So I will keep the 1 on. First place value I will keep on, this 2 I will keep off, this I will keep off. That means here this is the representation of 1. That means for 1 I will be getting here is 0 0 1, right? Now we have to show 2. Now out of these place values, which bit should be on? Obviously this 2 bit should be on. So what I will say here, 0 1 0. That means this 2 is represented as 0 1 0. Similarly, if there is 3, now to get 3, what should I do? I should activate this bit, that's 2. I should activate this plus as a bit as well. That will become 2 plus 1 is 3. That means this bit is on and this bit is on. This fourth one will be off. So this will become 3. Getting this point? 0 1 1 is the representation, binary representation of a 3. Now if you have to represent 4, so how will we represent 4? Obviously this 4 bit will be active and rest of the 2 bits will be off. That means it will become 1 0 0. Getting this point? Now if you have to represent 5, so what should be active? This 4 plus 1 is 5. That means these 2 bits should be active and this bit should be off. So 5 will become somehow like this, 1 0 1. Getting this point? Now if you have to represent the 7, so how will be represent 7? So place values you are having 4 2 1. To get a 7, that means 4 plus 2 is 6, 6 plus 1 is 7. That means all the 3 bits should be active. All the 3 bits should be active, right? This is the representation of your 7. Similarly, if you have to represent 8, to represent 8, can you represent 8 with the 3 bits? No, because the total, if I will add them up, this will become 7. To represent 8, that means I have to involve this one more bit, right? So that means 8 will become somehow like this, 1 0 0 0, because 8 bit will be activating and other 3 bits will be off, right? Similarly, if I have to represent 9, so what will do? 8 should be active. 8 plus 1 is 9. That means it will be somehow like this, 1 0 0 1, right? Now if you have to represent 12, how will you represent 12? 8 plus 2 is 8 plus 4 is 12, right? That means this bit and this bit should be active. These 2 bits should be off, right? To represent 12, I will say something like that. It must be 1 1 0 0, right? So obviously if let's say if I am saying there is a one number, there is a one number, my number is something like this, 1 0 1 1 0. Now what is this number? This is my binary representation, this is my binary representation. Now what is the binary sorry, decimal of this binary? So what I'll be doing is simply I'll be taking here one thing. Let me take the place values. I will say this is the 1, this is 2, this is 3, this is sorry 1 2 4, this is 8, and this is 16. What I will simply do, wherever there is an active bit, I will add those values. That means it will become 16 plus this 4 is also active plus 4 plus this 2 is also active plus 2. That means it will become 16 4 is 20, 20 plus 2 is 22. That means this value is 22 decimal. Getting this point? I hope you understood it, right? Simply wherever there is an active bit, you can see that that bit you have to add with the other bits, or you are considering that bit. Okay, this thing is clear. Now next thing what you have to see is how we will be converting decimal into binary. Getting this point? So there are many ways, so I will show you them one of the way. First way is like this. You can simply say that there is an input function. You will say bin of any number. Let's say I'm saying 5. If I will say bin of 5, so it will give me the output as 101, right? But this bin is an inbuilt function. That means someone has already wrote some code behind this bin. Getting this point? Take an example. You are doing the login. So when you are passing your email, when you are passing your password, then you are clicking on this login button. That means someone has already wrote the code behind this login button. Obviously then you are able to log in, right? Same thing here. Already someone has wrote it. So why you are using this? If someone has wrote it, that means you can also write it, na? Why to use this? Just create your own function, yeah, create your own program here for this bin, right? So don't use this bin as of now, right? So let's see the logic. So logic is like that. Suppose if I am having 5, now you know the binary of 5 is 101. So how to get this 101? So what? Okay guys, now see how we'll be performing this operation. So how I'll be getting this binary, and you understood how we are converting, yeah, how the decimal values are representing the binary. Now how we will be converting them into the binaries. Let's see that. Please understand here. So let's take an example. I'm having the 5 here. Let's take an example. I'm having the 5 here. Now to get the binary of this 5, so what we'll be doing is, obviously when you are having the binary you can say that it is represented with the 0 or it is represented with the 1. That means here binary base is 2. That means you are representing anything with the 0 or 1, right? Similarly, if I'm saying decimal, I'm saying decimal base is 10. How decimal base is 10? Because any number you can represent with 0 1 2 3 4 5 6 7 8 and 9, right? So combination of any these numbers can make any decimal number. That's why the base is here 10. Since in the binary you are having just the 0 1, that means the base is 2, right? For the decimal you are having these 9 numbers, you can say the base is 10. Suppose if I am having the we are having something called as the octagonal, right? Octa means anything that you are representing with these 8 numbers, 0 1 2 3 4 5 6 and 7, right? These are the 8 numbers with the octa. You can say anything that any number that you are representing with 0 to 7 numbers, that's your octagonal, right? Getting this point? Same thing. This is the base about the bases. Now we have to convert this 5 into the binary 5. So how we'll be doing it? See the operation please here. This is important. If you understood this thing, then you will understand half of the things. Let's take an example. We are having 5 here. So what I'll be doing is, obviously the base is 2. That means you have to divide with this base 2, right? So if the base is 10, so obviously you'll be dividing with the base 10. Since the base is 2 here, so what I'll be doing is I'll be dividing this 2, dividing this 5 with this 2. So obviously 2 3s are is 6, that's greater than this. So I will say 2 2s are is 4, right? Once you are getting the remainder, that means this remainder I am getting. This remainder you have to save somewhere, right? This remainder you have to save somewhere. So let's say I'm saving it here. I got the 1 here, the initial one, right? So when you are having this coefficient that you are having is this coefficient, you have to again divide with this dividend 2, right? So now I'll be taking the coefficient. What is my coefficient now? 2. Again I will divide it with the 2, right? So now 2 2s are is 4, that's extra. I will say 2 1s are, that's 2, and the remainder that you are getting here is 0, right? So again you got this reminder here. Now this 0 you have to attach with this 1, that means it should become somehow like 1 0. Getting this point? Now this coefficient is still 1, so what you'll be doing is you'll be again dividing this coefficient with the 2. So what I'll be doing here is I will take the 1 again divided with the 2. I will say 2 zeros are 0, right? And the remainder you are getting here is 1. Got it? Now you'll be taking this 1 and attaching it to the 101, right? This is your binary 5. So how, if you want to prove it, let's see prove. Take the place values, that is 1 2 4, right? Now how to get 5? These are my place values. That means this bit should be active and this bit should be active, this bit should be off. So it will be 1 0 1, because 4 plus 1 is 5. That means binary of 5 is this, and we are getting the same here, right? Let's take one more example. Suppose if I am having 9, suppose I have 9, what I'll do is to say, obviously I'll be dividing 2 4s are is 8. The remainder that I'm getting here is 1, right? So what should you do? You should take this 1, keep it somewhere, took this one, keep it somewhere. Now this coefficient is 4, again I will be dividing this coefficient 4, right? So again I will say 2 2s are is 4, remainder is now 0, right? So once you got this remainder 0, what should you do? You should take it and attach to the previous 1 0 I did. So coefficient here I am still having 2, so again I will take this 2, again I will divide it. 2 2s are is, sorry, 2 1s are is 2, the remainder here is 0, right? Take this 0, remainder 0, and add it to the previous one, add it to the previous one, right? Now coefficient you are having still 1. Will you stop here? No, again you will be dividing it. 1 2 1s are is 2, that's extra. I will go 2 zeros are, 2 zeros are is 0, remainder will be 1 here, right? Take this one and attach it here. That means you should stop only when this coefficient is 0, this coefficient is 0, right? So at the time you should stop, otherwise you should perform the division if coefficient is coming anything here. Now how to prove this? This is exactly 9. Take the place values. I'll say 1 2 4 8. So how we can get the 9? So 8, this bit should be added. 8 plus 1 is 9, that means it should be 1 0 0 1, right? So exactly we are getting a 1 0 1 here and 1 0 1 here. So that means here you are having something like this, 3 4 checks you have to do. The first check should be something like this. First check is you have to divide unless this coefficient is becoming 0. This coefficient is becoming what? 0. Got it? This is the first thing. Second thing is what you have to do, you have to take the remainder, right? You have to take the remainder, but this remainder you have to save in something, you have to save in something, right? And to that something you have to add the new remainder. Like I saved here 1, then added 0 to it, then I saved 1 0, then added 1 to it. Getting this point? That is the second thing. The third thing that you have to do is you have to perform the, you have to get the coefficient as well, you have to get the coefficient as well. These are the three things that you have to do, right? And okay, coefficient I have already discussed it. I will say the third thing is that you should stop when this coefficient is 0. You should stop when this coefficient is 0, or you can say that when this number is 0 itself, when this number is 0 itself. So at that time you'll be stopping. Why? Because when you are getting the 0 here, if the number is 0, so what you'll be doing, 2 zeros are is 0, so at the time you'll be returning 0. Got it? Got it? Hope you got it. Now so what I'll be doing is, let me show you this with a we can do this thing with a two ways. With a two ways I can do this thing. Let me show you this thing here. So understand here, you know about the string, you know about the string. So two ways are here. The first way is you can do it with the string, means whenever you are getting that remainder you will take the string. Second one is you can use the mathematical formula, same math formula, right? So now let's see with the let's see first with this string. So how we'll be doing with the string? So what I'll be doing is, so once I will taking one here binary, I'll be taking here one binary, and I'll be taking this binary as a string. I'll be taking this as a binary, as a string, as an empty string. Getting this point? So when you are doing this, 2 2s are 4, remainder is 1. This 1, obviously this is an integer 1, right? So what I'll be doing is I'll be converting this integer 1 to the string 1. I'll be converting this integer 1 to the string 1. And when I will do 1 plus this binary, because this is also string, this is also string, what will it become? It will become somehow like this 1. Okay, Again you will be performing the operation. Now once you are performing the operation, now this binary, the binary that you are having here, this binary is having now currently 1, right? So but this one is string 1, just remember it. So once again you are again perform the operation, so at the time what you are getting the remainder 0. So what you will be doing, convert this 0 into the string. I'll say 0, this is my string. Now what I'll be doing is, again this binary I'll be adding it with this reminder, right? So when you are adding, obviously this is string, this is string, obviously it will get concatenated. So it will get concatenated, it will become 1 0, right? So that means you have to use the formula somehow like this. This binary, that's your new binary, it should be equal to binary whatever is present over there plus string of reminder, right? So remainder you are getting integer. What should you do? You should convert it to the string, then add it to this binary. Well, now we are having 1 0 here. Again when we are performing this operation, now what is the reminder, reminder here 1. Obviously what you will do, you will be converting to the string, converted to the string. So what will be doing is binary plus string of reminder. What is my binary? That's 1 0. And what should I add it? This is this 1 0, string of 1 0. Obviously you know when you are performing the addition of the strings, it is becoming concatenation, it will become 1 0 1, and that is your this binary 5. I hope you answer, you got it. That means we should use this kind of a formula, but this binary should be string, and this remainder also we should convert into the string. Then when we perform the concatenation operation, then we'll get something like this 1 0 1, right? Now let's do this. I will say here num, I am receiving the num from the user. I will say int input, enter the number. Now user will give me the number. Getting this point? Now inside what we are doing is, first we are taking the coefficient. I will say q equal to, how to get the coefficient? Obviously which operation you will be doing is, you should get here this 2 1 something like this, right? So that means here we'll be doing the floor division. You know floor division and this normal division, integer division I can say. So what I'll be doing is floor division. I will say num divided by 2. This will give me the floor division. And what we need is remainder. Obviously remainder equal to num divide percentile 2. That means here we are using the modulus operation, here we are using what? Floor division, right? The third thing is, what we need is, we have to say something like this: binary equal to binary plus remainder, but remainder kya? Convert it to the string, right? Now initially this binary I'll be keeping as a string itself. Initially you have to keep the binary as a empty string. That means this binary is containing nothing now. Now this operation we have to perform कब तक? तब तक जब तक ना ये कोफिशिएंट क्या बन जाए 0, तब तक जब तक ना ये कोफिशिएंट 0 बन जाए. So what we'll be doing is, here we will be using some while loop. That means we'll be performing the operation again and again. So you can see here we are performing the division on this num. That means we have to update this num. Can I say that previously my num was 5, right? When I am performing second time the same operation, this num is becoming the coefficient, right? This 1 is becoming the coefficient, then, right? Then this 0 is becoming the coefficient. When the 0 is coefficient, at the time we should perform stop the operation. That means once this num is 5, next time this num should be equal to 2 here, next time this num should be equal to 1 here. So what I am doing here is, obviously these are my coefficients. So can I say here that num is equal to q, right? Because again and again we are performing the operation on num. We can't do it individually. That means we have to use here loop, right? So if I am keeping this coefficient in the num, so when I should stop? When this num is equal to 0. Can I say तब तक ये ऑपरेशन करो जब तक ना नंबर मेरा 0 बन जाए, जब तक ना मेरा कोफिशिएंट 0 बन जाए. दिस कोफिशिएंट में किस में रख रहा हूँ? नंबर में रख रहा हूँ बार बार, right? We should perform this operation again and again. Getting this point? So obviously this will be my thing here, and after that I will simply say here print binary. I will say here print binary. Getting this point? Now let's run it. I hope it will work fine. Yes. Let's say I'm saying here 5. What you are getting is 101. Got it? So how you are getting this 101 here? Let's see that thing. Let's dry run it, and I hope you will get it. Let me write the code here. Let me write the code here. So, hey guys, so I have wrote the same code here, as the code is looking like here. The same code is written here as well. Or now let's dry run it. So initially what we are saying, we are taking the input from the user. We are taking the input from the user. Let's say I'm giving here 5 as an input. 5 as an input I am giving here. That means this num is containing, this num is having one block of a code, a memory block, and in this memory block we are having 5. In this memory block what we are having is 5. After that we are creating one binary as well. And this binary is currently empty, right? Because this is an empty string, we are not keeping anything here, so it is an empty string, right? Now check while loop. Now let's check the while loop first. In a while loop what we are doing is we are doing something like this: while num not equal to 0. What is my num here? Num is now 5 here. Is 5 equal to 0? कंडीशन ट्रू, सॉरी, इज 5 नॉट इक्वल टू 0? क्या 5 0 के बराबर नहीं है? हाँ नहीं है, इट्स ट्रू, 5 0 के बराबर नहीं है. If it is true, where should we go? We should go inside here. And here what we are having? Q. And what is Q equal to? 5 divided by 2. And what is this division? Floor division. Do the floor division. What I will do here is 5 2. 2 2s are 4, remainder is 1, right? So with this division what we'll be getting here is 2. That means this Q is equal to what? 2 now. When you will perform this operation, this Q will be equal to 2. This Q will be equal to now 2. After that what you are saying? R equal to num percentile 2. So what you are doing here? Modulus division. So modulus division कैसे करते हैं? Same way में what I will do is 5 and here I will say 2. 2 2s are is 4. The remainder is 1. In a modulus division what you are taking? Remainder. What you are taking? Remainder. That means R is equal to 1 here. Got it? In this second this remainder wala thing. Then what we are doing is binary equal to binary plus str of remainder. That means this you are doing something like this. You are saying binary equal to binary. Go to the binary. What is here? Nothing we are having here. That means this is empty string plus string of remainder. What is my remainder? It is 1. Convert it to the string. It will become this one, right? Now what will happen here? Concatenation. So it will become 1. कौन सा 1? String वाला 1, right? That means now save this one back to the binary. So here we are saving it back to the binary. That means here we are getting 1. Getting this thing. Then here what we are doing? Num equal to Q. That means this number is now equal to Q. What is my Q? My Q is 2, right? Now inside num what you are having? 2. That means you will update here. You are not having 5 now. What you are having here? 2 now. Got it? So from here where we go? Back to this while loop. We'll be getting back to this while loop, right? Now what you'll be saying is, while num is not equal to 0. What is my num now? 2. 2 not equal to 0. Condition true or false? True. Where you will go? You will come inside. And what you are doing here? Q equal to num divided by 2. That means this Q now will have num. What is your num? You will go to the num location. What is present over here? 2 divided by 2. That means you will do the floor division and it will be equal to something like this. You will say 2 2s are is, sorry, 2 1s are is 2 and the remainder you will get 0. So what you are doing here? Floor division. That means you should take this coefficient and this Q will have now 1. That means this Q is containing what? 1 here, right? After that what you are doing? This operation. Remainder is equal to num percentile 2. That means this R is equal to num. What is my num? 2 percentile 2, right? So what should be equal to? Again you will do the division, right? So you are saying 2 1s are is 2. What is the remainder here? 0. So what you should get from here? Remainder. That means this R is equal to now 0. कौन सा वाला 0? Obviously integer 0, right? So after that you are performing this operation. Binary equal to binary plus string of remainder. So what you are saying is here binary equal to binary. Go to the binary. What is present here? 1. कौन सा वाला 1? String वाला 1, right? So you are having this string वाला 1 here plus you are saying string of remainder, sorry, remainder means string of r, I will say here. What's my r? This remainder na, string of remainder, that's r. What's my r? 0. Is 0 को किस में convert करो? String of 0 में, so it will become the string of 0. Add them up, what will become? 1 0. Save this 1 0 कहाँ पे? Binary पे, that means you will be having 1 0 here, correct? Now in the third iteration, what you will be doing is, third iteration में, before going to the third iteration, after performing this operation, you are performing this operation. What this operation is saying, whatever is in queue, save into the num, right? Whatever is in queue, save into the, what is inside my queue? 1. Where I'll be saving it? To the num. That means here I'll be updating it. Now it will be 1 here. Got it? Now after that, what we are doing, again we'll be doing the same operation. I will say, oh, okay, from here I'll again go back to this while loop. Now here num, what is my num value? It's not 2 now. What is my num value? Obviously it is what? 1. That means here is basically, after this I'll be having here 1. Is 1 not equal to 0? Condition true or false? Obviously condition is true. So what will be coming? You will be coming inside q. You will be coming inside q. And inside q, what you are saying? Q equal to num divided by 2. So q equal to num. What is my num now? Obviously 1. 1 divided by 2, right? So you will be doing something like this. It will become 1. 2 ones are is 2. So what I will do? 2 zeros are. 2 zeros are is 0. The remainder will become 1, right? So obviously this q will now have what? Coefficient. Q is storing the coefficient, right? That means this q will have here 0. That's your coefficient, right? Now next thing is remainder. So how remainder you are getting is num percentile 2. What is my num? My num is 1. So I will say 1 percentile 2, right? Now 1 percentile 2 you will be doing is, that means you have to take the remainder. So I will say here 1, 2, 2 zeros are is 0. The remainder you will get is here 1. Now take this 1, it will be stored in R. That means this 1 is stored in R. Got it? Then what operation will be performing? Binary equal to binary plus string of remainder. So that means your binary is equal to binary. Now what is inside my binary? It's 1 0. Which 1 0? Obviously string wala 1 0. String wala 1 0. And you will be adding this up with the remainder. What is my remainder now? 1, right? But this one you have to convert into the string. That means it will become 1 0 1, like this, right? Add them up, what will become? 1 0 1. It will become 1 0 1, and this 1 0 1 you will be storing here in this binary while allocation. Okay, so will you stop here? No. So what will you be doing? Next operation. What next operation is saying? Num equal to q. That means this num will be equal to q. What is my q now here? 0. That means this 0 is being stored in this num now. Got it? And after here, where you will go? You will go back to this while loop, right? That means this num is now 0. This num is now 0. Got it? So you'll be getting back to this while loop. So at the while loop, what you are saying is num equal to not equal to 0? Is num, what is num? Num now 0. 0 not equal to 0. क्या 0 0 के बराबर नहीं है? Condition true or false? False. Once the condition is false, will you go inside while loop? No. Where you will go? You will come here, and here you are printing binary. So what will be printing? 1 0 1. That means you got your binary file. Hope you understood it. And in the second video, next video, we'll be seeing how we'll be doing it mathematically. Okay, let me show you here only. So how we'll be doing it mathematically. Now to do it mathematically, what we have to do is, we do need to convert it into the string. We don't have to convert it into the string. So what we'll be doing instead what we'll be doing is, let's take an example. We are getting 1 here, right? After 1 we are getting the remainder as 0, right? That means the new thing that should become here is, it should become something like this, 10. Getting this point? After that, what we are getting is 1, right? That means the new thing that we should get here is, that should become 1 0 1. Now how to get this thing? So there is a formula. So formula is saying something like this: whatever the remainder you are getting, multiply that remainder with 10 raised power I, right? So sometimes it will be 10, then you have to make it 100. To make it 100, you have to multiply with this thing. This will be clear once I will show you. Remainder into 10 plus this bit that you are getting this remainder, right? Let's take an example. Initially I am getting the remainder as 1. initially I'm getting this 1 as a reminder, this one I'm getting as a reminder, right? So according to this formula, what it is saying, reminder into 10 raised power I, right? If I will take initially I value as 0, if I will take initially I value as 0, right? So it will become something like this. Reminder, what is my reminder? 1. 1 into 10 raised power 0. Oh, okay, here I will say the previous bit where you are saving it, previous bit, right? I will say 1 into 10 raised power 0, it will become what? 1 plus, let's say previous bit initially we are keeping the 0, so it will be 1 plus 0 is 1, right? This we will be saving in the previous bit, because you have to save the previous bit now. Now you got the 1. So after that you are getting the 0. This will be clear now. This will be clear now. Now you are getting the 0 in the second iteration. So what you'll be doing is do the same formula, use the same formula. Now remainder, what you are having as a remainder as 0, right? So again use the same thing. That means it will be 0 into 10 raised power. Now previously I was 0. Now I'll be incrementing I. It will become 10 raised power 1 plus previous bit. So it will become something like this. 0 into 10 raised power 1 is 1 plus, what is my previous bit? 1, right? It will become 1 here. Got it? So we have not used the 0 here, still we are having the 1. But what should we get? This 10. This 10 we should get, right? See now in the next iteration. In the next iteration, what I'll be doing is I'll be doing something like this. Now in the next iteration, obviously I am getting what? 1. In the next iteration, I am getting this one, correct? I'm getting this one. So what I'll be doing here is I'll be doing something like this, same formula I'll be using. So I will say reminder, what is my reminder? That is 1 now into 10 raised power. Previously it was 1, now I'll be incrementing it, it will be 10 raised power 2 plus previous bit. What is my previous bit? 1, right? So multiply it, it will be 1 into 10 raised power 2. So it will be somehow around 100 plus add this 1. You will be getting a 101. That's how you can do it with this formula, right? Rest of the things will be same. Rest of the things will be same. So what I'll be do here is I will do something like this. Okay, let me comment this thing here. Now I'll be doing the same thing. I will take the number from here. Obviously I have to take the number from the user. Control V. Now this binary I need? No. Instead of binary, I'll be taking a simple. I will take the simple this thing. I will say binary equal to 0. Initially binary equal to 0. Control C. Now I will not keep the empty string, I will keep it a integer as it is, right? The rest of the things will be same. The rest of the things will be same. So I will say Control C here, Control V. Let me remove here from these comment lines, right? So what I said here is, what you have to do is binary equal to binary. Binary is your new bit, that's your reminder. What I have to do is reminder into 10 raised power I plus the previous bit. Now my previous bit is present in the binary, plus what I have to do is reminder, right? Yes, reminder into 10 raised power what? I, right? Now what should be the i's value initially? Obviously I value initially it will be 0, so I'll be keeping initially I as 0. Got it? So after that what I have to do is, obviously I have to update this num equal to q. I will say num equal to q, right? Then what we have to do is we have to increment I this as well. Why? Because if it was I was 0, then you have to take from 0 to 1, from 1 to 2, right? That means you have to increment this I as well. I will say I plus equal to 1, right? That's it. And after that I will say print, and here I will say print binary. Got it? Now let's dry run it. Okay, so maybe it will be clear then. Here now let's dry run it. So obviously let's take number, we are taking the number as 5, right? We are taking the number as 5. Then we have created one slot here, one memory slot for the binary we are having here, and initially the value of the binary is 0, right? And we are also creating a I. My I is initially 0, and here I am having the number as well. Let's say I am having the number here as well, and this number is initially containing 5, right? So what we are saying is while num, that means 5, is 5 not equal to 0, condition true, ये बोल रहा है 5 0 के बराबर नहीं है, true or false? True, you will come inside. Q equal to num divided by 2. So now you know q will be equal to 2. 2 2s are 4, right? That will be q. Your r, remainder will be getting 1. Why? You can see it's like this: 5 2 2 2s are is 4, remainder is 1, that means coefficient 2 is 2 and the remainder is 1. That means I have kept here q equal to 2, remainder equal to 1. Then here, check here, this is showing something like this: binary equal to binary plus q into 10 raised per I. What is my I now? Initially 0. I is my 0. Let's elaborate it. What is my binary? Binary is 0. 0 plus q. What is my q? Sorry, r. R. It's r here, sorry. Reminder. R here. Binary plus r into 10 raised power 0. What is my r now? 1 into 10 raised power 0, right? So it will be equal to 0 plus anything raised power 0 is equal to 1, right? So it will be 0 plus into 1, so total it will be equal to 1. This 1 you will be saving in the binary. That means here instead of a 0, so what will be saying here? You will be saving here 1. Got it? Then what you are saying? Num equal to q. Now your num is equal to q. What is my q? 2. That means num will have now 2 here, right? After that, what you are doing? I plus equal to 1. That means 0 plus 1, it will be now 1 here. Got it? Now in the after here, so again you will go into this while loop. Now see the second iteration. In the second iteration, what I'll be doing is I'll be doing something like this. Again, here, what is my num? Obviously my num is 2. 2 not equal to 0. Condition true or false? Condition is true. Now why you are having q here? Now q is equal to num divided by 2. Take here 2. 2 1s are is 2. Remainder is 0. That means your coefficient is 1. That means q is 1. And remainder is 0. That means remainder is 0, right? So here what I am saying is binary equal to binary plus r into this. That means binary. What is my binary? It's 1 plus r. What is my r? Remainder, that is 0, into 10 raised power I. What is my I? 1. So what it will become is 1 plus 0 into anything, it is 0. That means it will become 1. That means your binary is still 1. This binary is still 1. Getting this point? And then what we are saying is num equal to q. That means update this num. Num is equal to q. What will be the q value here? 1. And you are increment the I as well. Num from 1, it will become 2, right? So from here again you will go back here. After you are getting back over there, so now what you will be writing is you will be writing something like this: while num, what is my num now? 1. Instead of 2, now it is 1. Is 1 not equal to 0? Condition true or false? True. What you will do? Q equal to num divided by 2. So what you are doing is you will be doing something like this. Now your num you are having 1 here. Since num is 1, you will be taking 1 here. 2 zeros are is 0, remainder is 0. That means here your coefficient that you are getting is 0 and the remainder that you are getting is also 0, right? Now check here, binary equal to binary. What is your binary? Go to the binary. What is present over here? 1. Take the 1 plus remainder. What is your remainder? Oh sorry, the remainder is here 1. 2 zeros are is 0, the remainder is 1, right? The remainder is 1 here. You will say r1, r is 1 here, into 10 raised power I. What is my I? 2. So what will it become? 1 plus 1 into 100. So what will it become? 1 plus 100. 1 plus 100 is equal to 101. That means your binary is equal to 101 now. Your binary is equal to now 101. Will you stop here? No. So after that, what you have to do is num equal to q. What is my q here? 0. Num equal to q. Q is my 0. That means you will get here 0, right? And I plus equal to 1. This I will become now 2 plus 1, that is 3. This I will become now 3. Getting this? So from here again you will be getting back to here. Now here what you are having? Num not equal to 0. What is your num? 0. 0 not equal to 0. Condition true or false? False, right? So once the condition is false, you will be coming here, print binary. Now what is your binary? 101. That's your, you will get the binary 101. Now check for any number. Let's say I am running this again. Let's say give me the 10. What is saying? 101. You can check it. 1 2 4 8. That means 8 and 2 is 8 plus 2 is 10. Take the 15. Let's take, I will take a 15. all are 3, that means 1 plus 2 is 3, 3 plus 2 is 4, 3 plus 4 is 7, 7 plus 8 is 15, right? So this is the case how you can convert any number into the binary, and you can see the calculation here how I have done it, right? So I hope you understood it. If you are having any kind of a doubt, so let me know. This is the one case converted the string that you don't need about this formula, bother about this formula, right? If you don't want to convert it the string, so you can use this mathematical formula here. Obviously you should be getting now what I am doing here and how I have done it. Thank you.